Sorry about that. Okay, can you hear me well? All right, so we're here to talk about how we're bringing React Native to 10, actually it's actually going to be 11, 10 different platforms over the next year, and what we've done so far. All right, so yeah, thanks for joining us and welcoming us here. So I'll talk about who You.i TV is. So I'm Dan, he's Dan, we both work for You.i. We're actually a software company that's strictly focused on media companies, on helping media companies actually deliver great experiences to their users. For example, some of the media companies that we've dealt with in the past, CFL, Turner. You might not be familiar with Turner, but you might be familiar with some of their brands like CNN, Cartoon Network, and things like that. NBA, we've worked with NBA here in Montreal, Radio Canada, and many more. So we help them deliver great experiences by empowering our designers. So we have designers on the team, and our product actually empowers them to basically let us build a product that is exactly what they're looking for, and that what they're actually coming up with. We'll talk about this a bit later. Our focus is specifically in media streaming applications, so either audio or video. We don't really mind, but our focus is absolutely media streaming. We actually support 10 platforms today. I'll go and list some of them a bit later. And the way we accomplish this is with a cross-platform product that we have. And it's a single code base for everything. We're based in Ottawa, like we mentioned, but we're not really downtown. We're in the suburbs of Ottawa. So I'll introduce myself. I'm Dan. This is Dan. I'm the new lead of the React Native team in our services group. So if I get anything wrong, I apologize. We're actually building React Native applications using our technology. So I work with Nicholas as well a bit. I've been at You.i for, Nicholas right there. I've been at You.i for a year. Previously in my career, I've done some work on macOS, iOS, Windows, and C# as well. And the only media app I'd worked on was something that syncs files to a phone, if you remember those days. And this is Dan. He's a tech lead on some of our projects. He's been at You.i for a year and a half. And previously, he came from a gaming background. That's actually really relevant. So the goal of this talk is I want to share you kind of what our technical journey's been. We're new to React Native. We're actually fairly new to JavaScript as well. And we also want to talk about what React Native brings to our technology, as well as what our technology brings to React Native as well. And we want to highlight some of the differences that there are in there, and we want to demo what we've built or what we can build with the technology as well. So for those that will be looking at the recording, unfortunately we'll have to cut it because you'll be seeing something here that will be revealed at CES. And I promise my slides are going to be more interesting in the near future. Okay, so here we go. So at the highest possible level, here's what we're doing with React Native, right? So there's already React Native on iOS and Android, and there's bindings for that. What we've actually built is we've built a React Native bridge to our existing product, the You.i engine. I'll go over in more detail what that is a bit later. So it's a fully fledged React Native platform, much like iOS and Android is. It's a full platform in itself. It's not, it supports 11 platforms like you can see here, but that's not, React Native knows nothing about that. The React Native layer knows very little about that information. It's all taken care of by our platform. So it's basically a proxy for those platforms. And it brings the cross-platform benefits of our engine to React Native. So we support 10 platforms today, and we'll support more later, but that means that we get Android, iOS, which React Native also already supports, tvOS as well, but it also opens up platforms that are not supported by React Native today, like Xbox One through UWP apps, Roku, Tizen, and other weirder platforms that you have in TVs. So for a fun fact, we started working on this on a hack day as well. So what is our product, the UI engine? So we've been building applications with this product for quite some time now. It is a proprietary product, but it is based on gaming technologies. So it is actually fully fledged game engine, but really we're using it for application development. But because it's actually running game engine logic in the back end, we're actually leveraging the hardware rendering capabilities of OpenGL, DirectX, or whatever, Metal probably in the future, to provide that optimized performance that those allow. We also get to run on really low-end hardware with our product because it really doesn't have that many requirements. We're not running the latest Assassin's Creed in there. We're running UI code, right? And the application is cross-platform, so it allows us to write code once, and it's the same code that runs on all these platforms. And basically, you have to customize a couple of things that are platform-specific sometimes, but essentially, you deal with 90% code reuse on a project. And on top of that, we have a designer workflow, which we hope to demo, and that's what empowers our designers a bit later. We'll demo that a bit later. So our background essentially is C++ with some Java, Objective-C, Swift, and things like that, as per required by the platform. So we're really far removed from what React.js is, right? And that actually brings up some challenges with our engine, with our technology. And brace yourself, this is my longest slide. So we actually love C++ development, but it's a bit verbose of a language to write UIs with. It's not exactly in vogue for front-end development. Hardly anything is written in C++ for front-end nowadays, except video games. And what that means is because it's not really in vogue, we don't really have access to open source libraries to run things on. Say we have to integrate with a service online. There's really nothing available. There's tons of open source libraries in C++, but it's more meant for system level stuff, right? So it's kind of limiting on that front. So when we write applications, odds are we have to write that stuff from scratch. There's really no other option. And when you write that from scratch, if stuff changes in the back end or you miss some key functionality, there's some technical debt possibly creeping up in this sort of stuff. So it's harder to maintain. Our technology for new people joining the company is really, it's not the easiest to learn. I mean, we have lots of documentation. It looks a bit like Qt if you've ever done Qt, but it's still proprietary. So the documentation only takes you so far. You can't Google for, if you have a question, you kind of have to ask the experts in the company to figure out where you need to go next, right? So it reduces the autonomy of the developers a bit more. So those are pretty significant challenges too. And those are on top of the challenges presented by the platforms that we deal with. I can give you an example. Roku by itself doesn't really let you run C++. It's using a different scripting language called BrightScript. Deployment's difficult, right? So they're not necessarily things that you expect from more modern development environments. They're not quite there yet, those platforms. It leaves us in a good place. We've been successful with that approach, but those are challenges that we've been trying to solve for a while. We can do better than that, right? And that's where React Native kind of started. We couldn't fix those problems in C++. There's just no way to get to there unless we built everything from scratch, or we had partners or external clients building us C++ libraries, or it just wasn't realistically attainable. We're still a fairly small company. So we chose React Native for a couple of reasons, but really is that we love the technology and it actually addresses the challenges that I've highlighted right on. So here's the reason that we actually like React Native. There's live reloading of changes. Right now, some of our C++ applications take 10 minutes to compile, right? So The feedback loop is super slow. Compiler caching helps, but it doesn't really get us where we want it. We also like how cross-platform is. We are a cross-platform company, so it is part of our ethos. It is something that we value a lot, especially with that fragmented market that we're operating in. It's really important to have that, and React Native is cross-platform. It also has a pretty thriving community of developers. You know, like I said, it is the case in C++, just not for app development. So it actually allows us to use some SDKs that are out there in the wild, which wasn't really the case in C++. So it does address our three challenges, right? The learning curves is still there, but a bit lower. We can reuse some code that's out there, and our amount of proprietary APIs has decreased. So there are some challenges with it, though. Our stack is not 100% identical to what's out there in React Native for Android and iOS today. We build our bindings to our engine, but it is definitely proprietary, right? But however, React Native sees it as a single platform. It is, so for example, you know, you could have a button.ios or .android.js. Well, you can have a button.ui.js if you want. It is a platform, even though we are targeting 11 different platforms. UI.js is kind of the same as JavaScript, but we also have a bunch of modules that are specific to our solutions, and we'll go over that shortly. So I wanted to show you an example of our C++ code. It doesn't really look great. It's pretty repetitive. This doesn't actually do much, right? We have, this only gets really the controls that are defined in our views, right? So you go to the root view and you search for stuff. It's not super efficient. There's no operations in there. It really just gets a reference. It's not really pretty, right? And here's how it looks in RN, right? So that changes. It's a lot more logical. It's actually broken. There's a hierarchy to it, which our C++ code doesn't have. So we do have JSX support of what we traditionally use in our applications. It's easier to read. There's operation logic in there. It's a bit bigger, but it's as a you know, expecting a modern development environment, it's a lot more readable. And on top of it, we've implemented some of the basic React Native controls with our engine as well. So for the first time, we can actually Google stuff when we have issues and try to figure out how things are supposed to work. So that's actually a huge deal for us because we just couldn't do that before. And it really allows our engineers to work on the code that matters the most, which is gluing everything together, integrating, and the actual modeling of the data. So that's what React Native brings to us. But we're also bringing some stuff to React Native from our end on the platform. So yeah, we are opening it up to 11 platforms, including TV, right? So TV right now is kind of a non-starter for React Native. Maybe UWP was getting there, but it was just not a really interesting proposition for our customers, right? And on top of it, we can guarantee there's going to be a single RN platform so the JavaScript code essentially should be one file. Even though we're targeting 11 platform, it will be one file. There might be some tweaks in there, but it should be one file because we are targeting a single platform from the JavaScript perspective. And we only have a single bridge implementation for our engine. So previously how React Native works is that there's a bridge for every platform that it supports. Our engine's an abstraction of the platform. So we've actually implemented a bridge to it, but you don't have to write a bridge for every different platform. So if there's an issue with the bridge, odds are it's an issue everywhere. It's going to be the same code on all the platforms that you run in for the bridge. So it's the same behavior going from our end to React Native to the actual C++ code. So it's the same thing, which is not the case with the other platforms. So the other thing too is that because we've built this on top of gaming technology, our view rendering is done directly at the metal level. So there's really no abstraction other than that bridge. So it allows us to run on low-end platforms as well. And then there's the workflow that I've talked about a bit. So let's talk about this now. So I want to talk about our designer workflow. So what we do here is that that was present in C++. It's nothing new with our React Native technology, but it was really important that we kept that going there. We use After Effects for designers. The designers actually take care of the view. And what I mean by that is they actually build the layout, they build the animations, they build the controls, and then they can export that, at which point our code can read that, interpret that, and then developers can make reference to that, those controls that are made and those animations and trigger them in code. So there's really, good sense for designers that they will get the application and the animations looking exactly like they wanted them to look like. Obviously, there's some back and forth with the developers sometimes, but really it's about getting the designers to work on the screens themselves. So here's what After Effects looks like for us. Hopefully it plays well. Yeah, it does. So this is a product description page that we call. Think of Netflix. You click on a show, it brings up a product description page. This is essentially what that looks like. That's what designers work on essentially. So they do all the animations. If you look at After Effects, which is the standard tool in the industry to animate stuff, there's a timeline there that defines the animations. If you move that through, it animates, and they're actually using the tool that they're used to use on a daily basis for animation. So, and engineers don't really have to worry about this. They don't have to worry about doing one-to-one, making sure that everything is pixel perfect on the screen, because that's actually taken care of by the designers. And funnily enough, our designers actually assign tasks. They're fixing bugs and they're contributing to the Git repo directly themselves. Might happen elsewhere, but it's not the most common situation. So in addition to that, in addition to the default controls we've implemented for our end, we support those compositions. So you can actually refer to these After Effects, which we call After Effects layouts, which we call compositions. And you can refer to them directly in JSX, as you would any other React Native control. So we're aware that there's other products that do that out in the wild for React and React Native, but we do want to, we really wanted to keep that because our designers really made pretty applications. So I'll explain the code a bit here, right? So you have the composition. PDP main is the name of the file that you would open. Load sync is something that we do on the engine side where it actually loads the composition in sync, it doesn't send it off to a different thread. The timelines actually, if you look bottom, the timelines actually represent the actual timeline that you would see in After Effects. So essentially it's an animation and it lets you put the timeline for that button and start playing it, right? And then there's button refs. So if there's an actual button in the After Effects, you can make a reference to it. So it's really not the exact same as the React Native that you're used to. It suits our needs well because it does keep what we had as an ethos for our C++ development. Dan's going to be showing that a bit more in detail after the talk. So it's not perfect. So we released this product, like 2 months ago? Yeah. Yeah. So it is a .0 release. It's not perfect. If you're used to writing React Native applications or React.js application, isn't everything that you expect it to work is not necessarily going to work. So there's limited implementation of some of the default React Native components that you're used to. So we're still early adopters, right? The tooling's not the same. So because we are dealing with the C++ code base, our tooling uses CMake underneath it to actually generate these projects. So it's not a pure web and NPM implementation, but we're moving towards aligning it to our end. So there are improvements to be made there. And we still have some proprietary APIs to learn. So all those compositions and everything, that's all new for someone to come. But there are massive improvements over what we've done so far. So, questions? Oh, yeah, you probably.
So we first did it on a hack day early in 2017, and then we ramped up a team to start working on this around August 2017, and then we released the basically 1.0 version in August of this year. So it was about a year of a full team working on it, of varying sizes throughout development, plus the hack day work that happened before then.
Oh, yeah, it was about 6 or 7 developers, but then as the project kept going, obviously more people had to bring in. So tooling was a big thing, right? Our tooling was fundamentally not compatible with what you would expect in React. So we had to step our game up there as well. So I think the product team is about, what, 20 engineers maybe? Yeah. So at the end, we had about 20 engineers working on that. So definitely a significant effort. Yeah. Yes.
In terms of maintenance on this support for you guys, I'm guessing like that
Yep. Yeah. Yeah. So the product team will have to keep on their own roadmaps to actually bring in new features from React into the product as well. So that's going to be a challenge. They'll have to maintain that. Hopefully there's no major changes. The good news is that it's our own revision of the engine. We're essentially a fork, right? We're not using exactly what's out there. We're forked. So if React changes, at least we have our own fork, and then we can plan for it and actually build it in there. But yeah, it's definitely going to be a challenge to keep up the speed to the latest there.
And we're actively planning for when they upgrade, what's it called, Fabric, the new React Native that's coming out. So yeah, we're very aware and actively planning to ingest that as well.
Yeah. Yes.
So the transition from After Effects to code, is that required?
Yeah. Yeah. So we have plugins in After Effects that export. They export to binary essentially, and our product reads that binary file and loads that in memory, and then basically they render based on that, right?
Like in After Effects to target like the platform, you have to add
That's essentially it. Yep. So we have markers and things like that that are not really in normal After Effects workflow, but we actually name them and then we can give them properties. So we actually have properties and controls to say, hey, do we want that list to have to snap, right, or things like that. Before it was all done on the After Effects side. Now with React, there's snap to interval and things like that we can invoke in code. But so there's actually more empowerment to the developers that we previously had. Anyone else? Yeah. Yeah, not me personally. I don't know. I can't answer that question. I could probably ask someone and get back to you in the meetup notes if you want me to dig into it. But that engine, the engine that we're actually using is quite, it's not recent. It's been around for 10 years, right? So, and earlier on, we weren't as focused on the TV market. Back when mobile started, it was still as fragmented as TV is today. We used that to write some mobile application. We kind of found our niche in the TV market because our engine really brought value in that market because of how fragmented it was. Yeah. Yeah. I can. What do we have on PlayStation?
NBA is on PlayStation.
Yeah.
We have, I'm trying to think. Yeah, I think we have 3 or 4 current applications. NBA is the only one that comes off my head. On Xbox, we have things like True TV, TBS TNT, a lot of properties for Turner. Those are just UWP apps.
They're only available in the States too.
Yeah. And I believe we have Fox is on.
Yeah, Fox in South America. Locally here, we have Radio Canada application, You.i TV on Android TV as well. Yeah. And Xbox, yeah. So we've had a lot of stuff. Most of our customers have been in North America so far. More questions? Yeah. Okay. Yeah. Yep. Yeah. So. Yeah, essentially, we have a focus solution. It's all abstracted out from the app level, but there are some bugs that creep up from time to time. But yeah, we have full focus management available for those platforms. Yeah.
We also have like focus management props, etc., for all our compositions in React Native. So I'll actually demo the focus specific things. I'm going to show you a 10-foot app once I show you the demo. So we can dive into that.
You ready for the demo? All right, let's get going. I will have to do that.
All right. My name is also Dan, so it's really easy to remember. I'll need to share my screen here. I think, oh, this is the application. Sorry, guys. Oh, it's up in this corner here. Share. All right. Cool. So I'll start by showing you the application. Keep in mind that this is a very up-to-the-minute demo that's being worked on. So its working state is currently unknown, but I did some testing before this and it should be all good. So you can build apps with a combination of JSX, sort of vanilla React Views, and After Effects. This one is much more After Effects heavy because we're developing it sort of to showcase what our engine can do. So you can see this is actually running on OS X, native OS X app. And it's just a lander with a bunch of shows, etc. You can click on a show, see a PDP, and you can see all the focus. This is the focus behavior that we just get out of the box, automatically calculated by the engine. And then if you want to, you can specify more specific things about focus per element in your compositions. You can do that in React code. And then if you go into a video, you'll see a video. Doesn't look like the Flash, but we're just getting all this data from the movie database. So yeah, this is the basic app. I'll show you a little bit more about, you know, how the designers might work with it. I'll show you some of the project itself. So we'll start there. You can see our projects are very similar to a normal React project. So we have our source code, we still have the node modules, we still have the package JSON, all things like that. And then we have this UI folder that has all our build scripts. This is just the Android template project that gets generated. And we also have our After Effects files that are dropped in here. So it's basically a normal React Native app with this one little platform folder for UI with all our specific engine things. And using these generate and build scripts, you can generate projects for any of the platforms. And then we have After Effects. So you can see we have compositions here for most of the things in our scene. And then right off the bat, you can see there's a search button. You can dive into that. You can see all the timelines here. So we have focus in, toggle on and off because this is a toggle button, things like that. And then instead of having to specify it in code, I can just throw in some markers here. Add some rotation. Now we're going to get a super cool spinny search button when we reload. So you can see here we have all our custom UI tools, scaling anchors for scaling to different screen sizes, We have a preview tool to preview compositions so designers can preview things outside of the apps. And then we just have an export to export whatever I've worked on. Unfortunately, live reloading is not currently supported for After Effects compositions, so we'll have to run the app again. But as soon as we do, you'll see we have a spinny load button. It's way too fast.
Trust us, it runs at 60 frames per second.
Yeah, it might be a little bit laggier on here than it is on our screen, but you can see proof is in the pudding. 58 at the top here. Yes, some other useful things. You're asking questions about focus. So if I open this, we have a custom dev panel here. So you can use most of your normal React dev tools, but we also have our own custom tools that we get out of the box. You can turn on or off hot reloading. You can see some more React specific information. You have things like inspecting scene nodes to see sort of what the composition name is, what their size is, things like that. The big one is the focus debugger. So this shows us what node is going to receive focus next, as is automatically calculated by the engine. So I can know that all my behavior is working right. Like you can see if I press up, it'll go here. It's hard to see since these are so close together, but it's a pretty useful tool. Yeah, and we can even slow it down so we can see like super awesome slow motion animations like an action movie. Yeah, so alongside your normal React tools, you get whatever dev tools we already had in the engine. And then I'll show you some of the code. So this is the code for one of our list items. You can see we just load an After Effects composition. And then within that composition, we have like buttons, images, stuff like that, that work pretty much how you'd expect those things to work in React Native, except we have this ref, which basically means we're not going to provide many style props to it. We're just going to take whatever the designers have given us and set behavior on it. Though some things like lists, we can specify some styles on them. Most of them, we just sort of get the reference and we bind our behavior, and then we don't have to write a bunch of style code in our actual JavaScript files. Yeah, so that's, I can add some text here. And then you can see once I reload. How are the animations playing? Oh, they're okay. See, now we've got descriptions on all our items. So yeah, that's the basics of the workflow and everything. Does anyone have any like questions about that? Anything else you want to see? Yeah. Yeah. So, I mean, you can use most of your normal React tools to start your diagnosis. And then one of the more useful ones, we have the asset viewer that shows us all the assets currently loaded into the app. So we can see like how much memory they're taking up, how big the assets are, and make sure they're sized to the compositions, things like that. So if you have like asset specific issues, you can look there. Otherwise, one of the really useful ones is alongside being able to see like the normal React scene tree, you can look at what under the hood we're getting from the engine, because we do have other things that we add to the scene tree outside of your normal like React tree. So this is basically a mapping to a bunch of React components. It's not one for one. What you get in the engine is what you specified in React Native. So you can see what nodes are hidden. As you scroll through, it shows you sort of what each, like it outlines each node. So if you do need to like dive deeper, you can use the tools here. Usually we'll start with normal React dev tools and then dive deeper as needed. Even for profiling things, we have like a FPS graph. Yeah, okay. it's working. I'm not seeing it on my screen. Yeah, does that answer your question?
And maybe you could show the actual JavaScript debugger that we have as well.
Yeah. So yeah, you can just turn on remote JS debugging and it works out of the box like you'd expect it to on a normal RN app. So you can breakpoint in, this is just a normal Xcode project, so I can breakpoint into the platform code with this, and then you can breakpoint JavaScript code, and it would show up in here as well. But it wouldn't show you like the stack all the way down to native.
There's actually a way to, I mean, it is our engine, so there's a way to get the source code going and then debug through that if we need to. Odds are we don't really have to do that. Like in our team, we're actually tasked in building the applications. Odds are we never really have to go down to that level, but sometimes we do.
Problem. Any other questions? Yeah. Yeah, so we have a essentially something called, I can actually write a little code sample. We have a concept called form factors. So in React Native, you would have like platform.select, and here we can do form factor.select, and then I can do like handset, and I want to render this thing, or TV, and I want to render this thing, if you really need to differentiate your code. Otherwise, it's pretty easy since it's all defined in AE, and this stuff is kind of style agnostic. If your tree is structured the same in a different form factor, then you can just use the same code. And then going back to After Effects, if I were to specify like a folder here called handset, then those compositions would be picked up by handset. And I could have the same named composition on TV that's laid out differently and is a different resolution and would be picked up by TV devices. So that's how you manage like the big difference between like a horizontal and a tall form factor of phone. And then beyond that, if you have like 720 to 1080 or whatever, you can just, it gets scaled by the engine automatically. So we have scaling anchors that you can just specify that define how things stretch and squish. Yeah. Yeah. Like what content we show, like the videos and stuff like that. Most clients have different backends. That's one of the big advantages that we got moving to React Native is we can just write fetch code like you normally would in JavaScript, whereas before in C++, parsing JSON in C++ is just a nightmare of boilerplate code. So yeah, we can just do it all like you normally would in any React Native app, and it changes for different clients. One thing that we found with a lot of clients is if they already have an existing web app, we're able to just piggyback off of that and use their existing like Redux implementation and all their data services that they already have. Just plug into that, and then all we have to do is write the front end, and all the data is already sort of there for us.
We definitely didn't have that before.
Yeah.
The other thing that we have is that our clients usually have DRM video or some sort of encryption of their video. We have a video component in our engine that actually does take care of the decrypting or the licensing for DRM. And here you go. So we have video ref, and that actually takes care of the license management for DRM or decryption for AS128 video. Yep.
Cool. Any other questions? Sorry, guys. All right. Well, I guess that about wraps us up. Thanks, everyone.
Thanks.